So, we've all seen what things like ChatGPT can do, right? It's mind blowing. It can write a poem, it can fix your code, it can explain a scientific paper in like 5 seconds. But there's a crack in the foundation, a huge one. For all that brilliance, these AIs are surprisingly bad at something we learn in grade school: math.
All right, so here's our game plan. We're going to look at the two big ideas behind AI, pinpoint exactly where things go wrong, and then dive into a pretty wild idea that the answer might not be in a computer at all, but in a physical object you can actually hold.
First up, the two minds of AI. See, to really get why AI struggles today, you have to understand this 50-year feud that started it all. So you had two camps, basically. In one corner, you had the NEETs, these symbolic AI folks. They thought intelligence was all about logic and clean, perfect rules. You know, if you could just write the perfect instruction manual, a computer could think. But in the other corner were the scruffies, or the connectionists. They were like, no way. Intelligence is messy. It bubbles up from this giant, tangled web of connections, kind of like our brains, learning from tons and tons of data. And for a long, long time, the NEETs were winning. Symbolic AI was the dominant idea. But then, look at this timeline. The Scruffies made a huge comeback. Geoffrey Hinton's work on deep learning in 2006 basically threw gas on the fire. Then in 2012, this neural network called AlexNet just blew everyone away in a huge competition. And that's at the stage for ChatGPT in 2022. It was the ultimate win for the Connectionist team. But that victory came with a serious catch. It turns out that being great at spotting patterns also created a massive blind spot, which brings us to AI's reasoning problem.
Yeah, and this quote really gets to the heart of the debate. Are these AIs actually thinking? Or are they just stochastic parrots, an amazing mimic that's just gotten incredibly good at remixing things it's already seen without a clue what any of it actually means? So some researchers came up with this really clever test to find out. They'd given AI a simple math problem, but they'd slip in one totally useless piece of information. Like, a farmer has 10 apples and 3 of them are green. How many apples does he have? The fact that they're green is completely irrelevant, right? And whoa, look at these results. On the regular problems, the AIs do fine. But the second you add that one distracting detail, the accuracy just tanks. It completely falls apart. And that's because the AI sees a number and a word, and its pattern matcher brain goes, oh, I've seen these together before, I should probably do some math with them. It's not reasoning, it's just reacting to a pattern.
Okay, so if the current approach is flawed, what's the alternative? Well, this is where things get really interesting. A new school of thought says the answer isn't more data, it's geometry. It's the shape of thought.
This idea is called geometric deep learning. And the core concept is, instead of just feeding an AI a billion examples, you teach it the rules of the world, the fundamental physical laws, things like symmetry. So instead of showing it a million pictures of a cat, you teach it the geometric idea of invariance, the rule that a cat is still a cat even if you flip the picture upside down. You're trying to bake the physics of reality right into the AI's DNA. Okay, don't let this image scare you. This is something called a principal bundle. You absolutely do not need to know the math behind it. Just think of it like this. It's a map of relationships. It teaches the AI the underlying grammar of how things connect and change in a predictable, consistent way. It's about understanding the deep structure of a problem, not just what it looks like on the surface. And here's another great example. This is a way to map a sphere called a heel-pix grid. The magic trick here is that every single one of those little shapes has the exact same area. Why does that matter? Because it hard codes a fundamental rule into the AI. No single part of the sphere is more important than any other. It's a kind of built-in fairness, a geometric truth the AI doesn't have to guess at. All right, so we're talking about all this abstract geometry, but how do we make it real? This is where we take a huge leap, from rulers to reality. What if mathematical truth wasn't just a concept? What if it was a physical object? This is where the science of metrology comes in. It's literally the science of measurement. You know, the whole reason a meter in the US is the same as a meter in Japan. You have these official bodies like NIST that are in charge of the official ruler, the physical object that defines what a meter or a kilogram is. It's the physical source of truth. And let me tell you, the process for keeping these standards is unbelievably rigorous. I mean, look at this list. You have to control the temperature, the humidity, document every single step, validate everything. It is a massive effort,
all to make sure that the standard is perfect and trustworthy anywhere in the world. Okay, so now for the big, wild idea from our source material. What if you could create a physical standard, not for a meter, but for honesty? This quote nails it. What if you could create the exact printer-ready coordinates for an object and say, here, use this to make everything else honest? Exactly. You stop just talking about ideas, and you actually ship the new ruler. The proposal is that you can 3D print a geometrically perfect object that becomes a new kind of standard, not for measuring distance, but for calibrating logic and reason itself. And that brings us to our final section, a universe in 3D print. This is where it gets really mind-bending. The claim here is that a $3 piece of plastic could literally help us prove some of the deepest mathematical conjectures out there.
And here's the thing, this isn't just some abstract theory. The source lays out a real-world $20 experiment you could do at home. Seriously, you 3D print this specific shape, glue on a cheap sensor, and then you just squash it. And the prediction is that the data you get from that little plastic thing collapsing will perfectly match a value from a super advanced area of number theory. It's a physical test for a mathematical truth.
Now, this is the most important part to understand, and it's absolutely wild. Look at this table. The claim is that when you squash one of these 3D printed toruses, you are not doing something like a complex physics calculation called a renormalization group flow. No, you are literally running that calculation in the physical world. The plastic collapsing is the math happening. A point from deep number theory isn't being represented by the collapse. It is being created by the collapse. It's a physical computation.
And it goes even deeper. The source material claims that different shapes are basically tuned to different mathematical problems. One shape might reveal patterns in prime numbers. Another might generate points on an elliptic curve. The idea is that each one of these 3D prints is like a proof-generating machine. And if we can build a whole library of these physical proofs, well, that might be the rock-solid foundation for an AI that can actually reason. Which leaves us with a pretty stunning question, doesn't it? For decades, we've been trying to build intelligence inside of a computer chip, using code and logic. But what if the next great leap forward isn't about code at all? What if the future of intelligence is printable?